All right, page 2. So whenever I have something like this, I like to factor it. And always the first step of factoring is to take out any common thing, which this has an x squared in. So I have an x squared, and if I take an x squared out of x to the third, I have an x. X squared times x is x to the third. And negative 4 times x squared is negative 4x squared. So that's what the numerator factors to. And the denominator factors, and again, if you don't know how to factor, you can always use the calculator to help you. You can type in x squared minus 3x minus 4 into y equals and see where the zeros are. Those would determine your factors. But this factors to x minus 4 and x plus 1, because negative 4 times 1 is negative 4. The outsides and the insides will make the negative 3x. Negative 4x plus 1x is negative 3x. So that's how it factors. Now, first thing it asks for is vertical asymptotes. Anything that makes the denominator 0 will create a vertical asymptote as long as it's not a whole. So down here, part C, we notice that these two factors are the same. So we have a whole at 4. And to find out what the other part of the whole is, you put 4 into the reduced equation. When these are canceled, we get x squared over x plus 1. This is not equal because this one you can't use 4, this one you can. So these are similar looking, but this one has a hole in it. And the hole is at, let's see, 4 plus 1 is 5. And 4 squared is 16. So that's the same as 4 and 3 1/5. So I'm going to jump down to the graph and put the hole on it. I'll draw my x-axis here. My y-axis I'll put here. X, y, and I'll make each one 1, 2, 1, 2, 3, 4 at 4 and 1, 2, 3 and 1/5. There's a hole. Okay? All right. So going back to this, now we can do the vertical asymptotes. Anything that makes the denominator equal to 0, that would be negative 1. So the vertical asymptote is a line, a vertical line. It's x equal negative 1. So now I'm going to go down the graph, and at x equal negative 1, I'm going to draw a dotted line for the vertical asymptote. Okay? Labeling my units. All right. Now determine horizontal or slant asymptotes, if any. Well, we have a degree that's greater in the numerator by 1 over the denominator. So we need to do long division. This is simple enough. We could just do synthetic division. I'll do them both. So I can do x plus 1 into the numerator, x squared. X times what makes x squared? That would be x. X times x is x squared. X times 1 is x. I draw the line, change the sign so that I can now add. That plus that is nothing, and this plus that is negative x. X, what times x makes negative x? That would be negative 1. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. Draw the line, change the signs, add. Those are gone. That 1 plus nothing is 1. So I get plus 1 over x minus 1. And as x gets large, this will go to 0. because the denominator will get large and this will be 0. As x gets large, positive or negative, this whole fraction goes to 0. And I get closer and closer to the line y equals x minus 1. So my horizontal or slant oblique asymptote is y equals x minus 1. So I'm going to draw that in. That's a slope of 1 through minus 1 on the y-axis. Through minus 1 with a slope of 1. Now, the graph cannot cross the vertical asymptote, but it can cross the horizontal asymptote. It just gets closer and closer to it as x gets really large and really small. So it's going down this way and it's going up this way. Now, to determine a little bit more here, let's find the intercepts. So if I want to find the x-intercepts, I make y equals 0. So that's 0. And the only way to make a fraction 0 is have the numerator be 0. Well, we could use this one, and that would be 4, or 0 will make the numerator 0. But 4 is the whole, so we don't worry about that. So we say 0 is, when we make y be 0, we get x be 0. So we have an intercept for both x and y axis of 0, 0. Now let's look for y-intercepts. That would be put in 0 for the x's, and we can again use this, and we get 0 over 1, which is 0. So we didn't learn anything new on that. In this particular one, both the x and y-intercept are 0, 0. Now, if it only touches there, it has to go to the hole, and it has to do something at the vertical asymptote. So it says determine what happens, determine the function behavior near the vertical asymptote. So I'm going to look again at the reduced form and not this, and I'm going to go close to the vertical asymptote, which is at minus 1. If I go close to it on this side, the positive side, it's negative 0.9. Negative 0.9 squared is going to be positive over negative 0.9 plus 1 is 0.1. So this will be bigger than this, and so this is going to be a big number. It's positive divided by positive. It's positive. So it's going to go towards the positive side of this. And I could put negative 1.1 in and see what's going on. See, negative 1.1 squared would be positive, and negative 1.1 plus 1 would be negative in the denominator. It's going to go towards negative on this side. But I knew that already because this is a single factor in the denominator. It's not a double. If it's a double, they go on the same side of the line, either down or up. If it's a single factor, they go opposite. So if it went down on the right side, it goes up on the left, and vice versa. So we have a case of the opposites. And so near asymptote on right side goes to positive infinity. Near asymptote on left goes to negative infinity. So it goes to negative infinity, goes to positive infinity. So if it hits here and only there, it can't go below, so it must just bounce there and then head to the hole and continue on, getting closer and closer to the oblique asymptote and closer to the vertical asymptote without crossing it. And then on this side, about the same distance out and everything, so somewhere around in here it's going to do the same thing on the other side. But there won't be a hole on this side. So judging by this crosses here. If I go over 1 and up 2, over 1 and down 2 from the crossing point, it's probably a point on the graph. I can check that by putting -2 in the equation and see if I get -4. -2 squared is 4 over -2 plus 1 is -2 plus 1 is -1. 4 over -1 is -4. It does go through -2, -4, and goes through 0, 0, and 4, 3 1/5 is the whole. So I've labeled things, so I should label on here, this is x equal -1 for the vertical asymptote. The slant asymptote is y equals x -1. And there I've got all the information on my graph. And if you get your information labeled well and draw it well, you get full credit. Okay, I've kind of drifted down in here for this box, so I'll do number 4 right above it. Write a degree 3 polynomial that has these zeros: 4, -3i, and so if it's -3i, there has to be a +3i because the imaginary always come in conjugate pairs. This is 0 -3i, so 0 +3i. So the polynomial must be x -4, because 4 is the 0. It must be x minus a -3i, which is +3i, and x minus a +3i, and it doesn't say any specific one. You don't have to hit a certain point, so this would be a function that has those 3. Now if you were to multiply this out, you might earn a few bonus points. Let's see, let's multiply the i's parts together. X times x is x squared. We're going to get x times -3i and x times a +3i. Those two are going to be equal and opposite, so they're going to cancel, so I'm not even going to bother writing those. And then I'm going to get 3i times -3i, so that's going to be a -9i squared. I haven't multiplied by the x -4 yet, but I want to simplify this part, this -9i squared. I squared, just by itself, is -1. I squared is -1. You should remember that. So, this is -1 times -9 is +9. So we have x -4 times x squared plus 9. And if I distribute here, I get x to the third minus 4x squared plus 9x minus 36. That's not too bad to multiply those out. And either f of x equals this or this would be an ideal answer. Now, this final one, 5. We have something here that we know all the zeros at. This is a function that's going to cross, actually this is going to bounce at +1. So we know this is where there's a bounce. It crosses at +6. It does a cross, so we don't know whether it's going up or down. And it crosses at -3. And so we have x squared would come out of this times an x times this. This is a fourth degree. So both ends are either up or both ends are down. But since it's the positive x times a positive x squared times a positive x times a positive x, it's going to be going positive on this end. It crosses at 6. It bounces at 1, because that was a double. And then it crosses at -3. So without even knowing how far up and down, no scale on the y, I know it has to look like this where it crosses the x. So all of this is the y values for this. It's kind of like y equals all of this. And we want to know when that y is greater than or equal to 0. For what x's is the y greater than 0? So the y is greater than 0 out here and equal to 0. So for 6 to infinity, for all those x's, and it can be equal, so we'll keep the 6. This is positive. It's greater than or equal to 0. It's not greater than 0 at 1, but it's equal to 0 at 1, so I have to throw that in there. So from 1 to 1, no interval there, it's right on top of itself, that 1 point. And then it's also greater than 0 over here for, so I got to write or, and for over here it's from -infinity up to -3. For all these x's, put in here, this will be positive. For that 1 point, which is 1 in the x, from 1 to 1 in the x, this is not the point 1, 1, that's up here. This is the interval from 1 to 1. And then from the interval from 6 to infinity, from 6 and on, including the 6, this is 0 or more. So there's the solution to that one.